Hello everyone, I am Sunanda from SNS College of Technology, Department of Mathematics. As the continuation of the lecture series in the topic standard distributions, we are going to see what is exponential distribution in this lecture video. So in many practical situations, we are interested not in the number of events, but in the time between two consecutive events. So in examples such as take time taken for a machine failure, waiting time for a customer, life duration of electronic components. In such cases, exponential distribution is used to model such continuous random variables. So, exponential distribution is a continuous probability distribution. It describes the probability distribution of waiting time until the next event occurs. So like the important parameter is lambda called the rate parameter. The higher value of lambda indicates event occur more frequently. Like in real life cases like spreading of virus, finances, nuclear chain reactions, pyramid schemes, bacterial growth and human population are one of such examples for exponential distributions growth. So here is a dt with exponential distribution method. Unknown repair time, that will be empathy calculation part, calculate exceeding 9 hours, exceeding 10 hours and the known repair time. So the probability density function of exponential distribution is lambda e power minus lambda x, where this lambda represents the rate parameter and x represents the waiting time. The function describes the likelihood of a particular waiting time occurring. So here in this exponential distribution, we are having one property called memoryless property. Before that, let us see what is what are the formulas for mean and variance. So here f of x comma lambda is 1 minus e power minus lambda x, and e of x, that is mean, is nothing but 1 by lambda, and variance is 1 by lambda square. So here is the moment generating function. Mx of t is lambda by lambda minus t, and variance is e of x square minus e of x the whole square, which is equal to 1 minus lambda square. So here this is the exponential curve, and here is the memoryless property. This is one of the important characteristics of exponential distribution. This means that the probability of an event occurring in a future depends only on the future interval and not on the time already passed. So for example, if a machine has already worked for some years, that doesn't mean that the probability of failure in the next period depends only on the upcoming period. So this property makes exponential distribution useful in reliability studies. So let us see one problem. So in the given problem, the parameter rate is identified. Next, using the exponential probability formula, the required probability is calculated. That is, first we have identified the lambda value. After that, substitution the given time value. Next, exponential formula is applied and the calculation of probability is done. So the length of time a person speaks over phone follows exponential distribution with a mean 6. So here the mean value is 6, and the probabilities of more than 8 minutes and more between 4 to 8 minutes is calculated. So for more than, the answer is 0.24982. So here is a mind map of what we have seen in this lecture video. First we have seen what is a exponential distribution, then we have seen a dt based approach to this, and here is let me explain one application. So applications of exponential distribution are reliability analysis, queuing theory, maintenance scheduling, live testing of components. So it is a continuous distribution, it models waiting time, and it has memoryless property, and it's widely used in many engineering fields. So here is an assessment. So if a random variable x follows an exponential distribution with rate of parameter lambda, then expected value is 1 by lambda. Next, in an average time between customer arrival at a store is 5 minutes and the process follows an exponential distribution. So what will be the rate? So using the formula p of x is equal to a of x lambda power x. So we are having the answer is using the formula we can calculate this. Here are the references, and thank you.